All right. I'm here with, is it Dr. Tom Murphy?
It's Tom.
Tom, who you describe yourself as a recovering physicist. Is that correct?
Yeah. Recovering astrophysicist or physicist, either one fits.
Astrophysicist. So,
Yeah.
what is it specifically that you're recovering from?
Well, it was a career I spent, I was a grad student at Caltech, and I did a lot of observational astronomy and building instruments for telescopes and looking at colliding galaxies. And it was, tremendous fun. And then started a professional career as a professor where my main research was shooting lasers at the reflectors that the astronauts left on the moon to get millimeter accuracy measurements between Earth and Moon as a way to test whether general relativity was holding up. So
Hmm.
just as here's an actual laboratory of the universe. Let's see what it has to say and not what, a particular Einstein, for instance, had to say, and see if he's right. So it was definitely a lot of fun. I built a lot of things that worked. But during that whole time, I was growing increasingly skeptical of the entire enterprise of modernity. And at some point decided that I didn't want to play that game anymore. And so now I'm recovering from, wasted years of playing for the wrong team, in a sense.
So, I mean, this is particularly poignant because you were at the cutting edge of modernity in some ways,
Oh, sure.
right?
Yeah.
At least in terms of technology and scientific research. Before we just leave it in the distance, though, how did Einstein do?
Well, it turns out that the test I was doing was very hard to get the theory and the model to work also at the millimeter level. But I would say that, just to put things in context, general relativity imposes kind of 10-meter scale wiggles on the moon's orbit, on the shape of the moon's orbit, that are detectable. And by testing to millimeter accuracy, you can understand to high precision whether it's surviving. So I would say that at least at the 1 part in 1,000 level, at the centimeter level, it's holding up. It looks like general relativity.
Hmm.
Whether, pushing down to the millimeter level, the measurements are now there, and it's a question of whether the model can catch up to the measurement precision at this point to differentiate whether the moon's orbit is really following general relativity is still up in the air, because there's so many things at the millimeter scale that interfere with your, understanding of the situation, because the Earth's surface is floppy. We think of it as solid, but even this experiment was in New Mexico, in the mountains of New Mexico, and tides we think of as affecting just water, just the ocean. But no, the entire Earth is bulging and sort of flexing
Really?
at the sort of, third of a meter scale daily.
Really? Huh.
Yeah. And so it's all moving around, ocean loading. So even though I was in New Mexico, this telescope was in New Mexico, water piling up on the California coast at high tide presses down the Earth.
Hmm.
After a large rain in the area, or snow, you've got a lot of mass pressing down on the Earth, and it's not perfectly rigid. So all of these things can move you around them at the millimeter scale, and it just is a challenge. But so far, general relativity has held up.
Is there any way to isolate your instrumentation from those fluctuations? Like for example, if you had an instrument on a extremely stable platform that was suspended, from helium balloons, and then sort of anchored to the earth at several different points with springs, something. Is there a way, or is the atmosphere itself also moving with those bulges and the?
Oh, you bet.
Yeah.
Yeah. And what you've described is an extremely floppy situation that would.
You have winds and everything else.
And
happening.
you said springs. Oh my gosh. Well, everything is a spring. The Earth is a spring.
Right.
So the best you can do really is bedrock, and,
but even
nothing is
liquid.
perfectly rigid. Right.
Yeah. I was camping a couple of weeks ago with Anya. We were and we were looking at this hillside, and you could see where big chunks of rock had broken off from the rock at the top of the hill, and some of them had rolled down or slid down the hillside in different ways. And we had this realization that it was moving just very, very slowly.
Right.
And what we were looking at looked static, but it's actually liquid. It's actually, and everything is moving just at different speeds.
Yeah.
And
yeah, that's right.
It's fascinating.
In fact, if you do a time lapse of a fire in a fireplace, you think of these solid logs burning, but you just see them melt. You just see them slowly collapse and ooze out into the ash and the coals. It's really kind of interesting that our temporal sensitivity just isn't really good enough to understand these larger scales, even at the hours level.
Right. Did you, as a physicist, there are certain things in physics that, I'm aware of. I'm a dilettante for sure, but, I have, I think, a very pedestrian understanding of the general theory of relativity or, quantum mechanics or things like that. But there are concepts that I understand as a concept, but I've never been able to integrate into my sense of reality.
Okay, that's fair.
So, for example, the classic one is right now my elbow is resting on this desk, which is, to my perception, obviously solid. If I bang my head against it, it would hurt. But according to physics, it's 95% empty space between the atoms?
Yeah, in fact, 99.95% of the mass is in
even worse.
The tiny nuggets of the nucleus. But whether or not the desk is solid depends on who you ask. If you ask a neutron that can travel through without electromagnetic kind of entanglements, it'll say, yeah, man, I'm sailing straight through. This is like, there's nothing here until, oops, it hit a nucleus. And so to a neutron, it's mostly empty space. To a neutrino, almost everything is basically empty space.
Right.
To an electron, however, it's going to bump into the electron clouds that are kind of filling the space.
So it's hitting energy, right? I mean, that's what the electron cloud is, a field of energy.
Yeah, it's kind of a charge. I mean, energy is definitely involved. But it's kind of a charge distribution, kind of probabilistic, fuzzy, pervading the space. And then a photon, a light, depends on what the wavelength is. A gamma ray is going to shoot right through and not really care about much of what's there. But a visible wavelength piece of light hitting that will say, oh, there are electrons here. I'm not high enough energy to sort of plow right through these things. They're interacting with me. They're sort of grabby. And so, it's a context, right? Everything is context. Right. And this is another one of those cases where it depends on how you cast it. Yeah, almost all the mass is in these tiny little nuggets that are 100,000 times smaller than the size of the atoms themselves, the electron clouds. And so in terms of empty space, it's a part in 10 to the 15, roughly, of the space is occupied by the majority of the mass. But it's a complicated story. It's not a single answer.
Okay, last I don't get to speak to physicists very often, so I've accumulated, a bunch of questions for you. This is the last one I'll bother you with, maybe.
Okay, no promises.
Gravity.
Yeah.
Does anyone understand how gravity works, or is gravity just one of those things that's accepted as sort of a baseline assumption from which we can then talk about other things? Like mechanically, how does the mass of the sun reach across the vacuum of space and exert force on other massive objects with which it has no contact? Like, do people understand that? I know they can describe it in great detail, exactly, what you can expect to happen based on this mass and the velocity and all that. But does anyone really understand how I mean, I guess it's the same as the forces between neutrons and electrons. Like, although my understanding is that's electrical, right? That's like a magnetic thing.
It's electromagnetic, but that still
Right.
reaches across empty space.
Yeah, just very small
Yeah.
spans, right? But how
Yeah.
does a galaxy reach across space and affect the movement of another galaxy?
So there are all kinds of ways to describe it, but again, they're only going to be descriptions.
Okay.
I would say nobody understands how it works or why it
That's what I was
works.
hoping you'd say. It
Yeah,
seems totally mysterious to a layman.
right. I mean, we can definitely, as you say, describe and predict and quantify and measure and test and all that, so we can understand the properties, the behaviors extraordinarily well. And in fact, we can get deeper insights into when it comes to things like general relativity, that it's viewed as a geometrical distortion of space and time,
Hmm.
which is really difficult to get our heads around, but it's possible to describe certainly mathematically and kind of get glimmers of how that works mentally. And so I can answer those questions in kind of a standard physics way of what we do kind of know. But, at the end of the day, a 6-year-old can keep asking why, and after only 4 levels, you're out. Any physicist in the world is
That's
going to be,
right.
tapped out. Like, I don't know. It is, right? It
Shot
is what
my
it is.
clip, kid. Yeah.
Right. So, but, I would say that, I mean, electromagnetism is 40 orders of magnitude more powerful than gravity. In other words, if you have a proton and an electron, the constituents of a hydrogen atom, for instance, there is a gravitational force between those two, but it's 40 orders of magnitude. That's 10 with 40 zeros, times smaller than the electromagnetic. And so the Earth and the moon are full of protons and electrons, and they absolutely feel each other, but all of those are basically canceled out by having a net zero charge, no net charge. They're neutral, as
Hmm.
many electrons as protons, for instance. So gravity doesn't have any canceling qualities. It doesn't have negative mass, so you can't balance it out. And so gravity is the one that can't be shielded, can't be neutralized, and it's just always there. Now, when you talk about kind of a quantum level interaction of how these forces are experienced, they're exchange particles. It's kind of like a proton and electron are constantly throwing photons back and forth as the communicator of electromagnetism. And they're called virtual particles because they don't exist on their own. They're sort of borrowed out of the vacuum for a bit. And you can borrow a lot of energy for a short amount of time. It's a Heisenberg thing. But yeah, these things are basically playing catch all the time between these photons. And the farther you get them apart, the longer it takes for that speed of light interaction to transpire. And so you can't borrow much energy for that longer time. And so as you go farther away, it's a less and less energetic interaction, less strong. And
Hmm.
it's just geometrical in terms of, the farther you are, the more spread out that field has to be. And the surface of a sphere gets, bigger according to the square of the radius, and the strength also of electromagnetism diminishes by that same 1 over r squared, inverse square law. So same with gravity, but with gravity, you never shield it.
So, if I understand what you're saying, there's between two massive objects, there's a certain amount of energetic attraction between them.
Mm-hmm.
And that doesn't change when they grow more distant. That amount of energy remains the same, but it's more dispersed now because of the greater distance between them.
So there is a dispersal. You could definitely see it that geometric way, but I would also say the energy of those exchange particles is going down as you increase the distance.
But even though they're traveling further distance,
Mm-hmm.
right?
Yeah.
Assuming if we're talking about them as particles, they're
Yeah.
moving further at the
Right.
same speed. They're always traveling at the speed of light.
Yeah. Those exchange photons.
Right. So, but it's strange to think that there's less energy when they're covering more distance. You would think that would be more energy.
Yeah. No, the distance, distance doesn't matter to a photon. It doesn't take more energy to go farther. It's not using it up. It's not like a gas tank. It's not pushing through any medium that's resisting it.
So it's not converting energy to movement.
No. I mean, it's a constant energy in its motion, if you will, but that's not decreasing or getting tapped off or bled out or depleted.
You don't get a spent proton.
No, they don't get spent. And so gravity, we would say in that same kind of context, we would talk about gravitons as the exchange particle, except that that's not something, I mean, we can see photons literally with our eyes. I've seen in the laboratory the electronics registering single photons and even measured their speed through.
So they're not just a concept. It's a physical entity.
It's something we can measure, right? But gravitons, those remain elusive. They're just really weak. And, part of the problem there, again, is 10 to the 40 times weaker than electromagnetism. So it makes measurements really hard. I mean, you don't see items in your laboratory attracting each other gravitationally. You can contrive to sense some of those things in some clever experiments that I've been tangentially involved with. But it's hard. Gravity is really hard. So you really need kind of astronomical size collections of bodies before you start to notice the gravity. It takes a lot of matter.
And are gravitons real, or is just a conceptual cheat that helps to calculate and think about it?
Well, depends on who you ask.
We get down to the question, what's real mean, right?
They likely are real, but just beyond our ability to sense. And so, I mean, just one way to see gravity, I've even got something right here. Is this on video as well?
Yeah. And so, if you're comfortable, I can post the video. If you'd rather just keep it audio, that's fine too.
Yeah, no, I'm fine with it. And for those just listening, it's not hard to visualize what I'm going to show. Is that got a steel ball and a little magnet, and this magnet can lift this steel ball against the gravity of the Earth.
Right.
So that's pretty amazing that something I can hold in my hand can defeat the pull of the entire Earth. I mean, that's an enormous amount of mass that's pulling it, but it's so weak compared to electromagnetism that something I hold in my hand easily defeats it.
I see. Right.
And you can rub a balloon on your head and then stick it on the wall, and it'll stick by electromagnetic kind of attraction, again, defeating the entire Earth's pull. So lots of examples of electromagnetism totally defeating. That was really weird. I have this one steel ball that's not very magnetic, and that's the one that I happen to pick. So I'm just going to do this again with a more convincing, you can see it leap up out of my hand now, this ball when the magnet grabbed it. So anyway, gravity is very weak. It's hard to study. In a geometrical sense, in a general relativistic sense, you would say that gravity, or the presence of mass, warps space-time. And space-time itself is hard to get our heads around because we separate time and space in our minds, which makes total sense, because if you're not traveling near the speed of light, or you don't have, light speed daily interactions of other particles moving past, I mean, you actually do. Muons are hitting you, photons come in at the speed of light all the time, but we don't notice them. If we were more tuned in, we would have a better sense of space and time as being a mixture, and one person's space can become another person's time, or some mixture of those. But when you curve those things, that you're trying to travel the straightest line through space-time, but as space-time gets curved, that trajectory might look curved in our space.
Right.
And so the path of a ball flying through the room in an arc, that arc is actually the straightest line it can travel in a curved space-time. Or an orbit we think of as a closed circle, but if you have a time axis, it's more like a helix that's wrapping, up through the time axis, and it's stretched out pretty far because time moves pretty fast. We travel the speed of light through time, which is a weird thing to say, but it's true in a sense. That helix is really fairly straight already once you stretch it out enormously in the time axis. But those subtle curves are curvature in in the geometry of space-time that it's traveling through because of the presence of mass.
Right. Do, I used to live with a woman in LA. She was my landlady. One of the coolest people I've ever known. Ginger Norwood was her name. She was one of the first women to work at NASA. She designed, she was 90, I think 92 or something when she died a few years ago. So we're talking these, she went to MIT. They weren't giving PhDs to women at the time. So I guess she got a master's degree, and then she fell in love with one of her professors, and he took a job at Yale, and they allowed her to attend doctoral level courses at Yale, but they wouldn't give her a degree, but she could sit in on the classes, right? Anyway, she designed the communications module for the Landsat, the first satellite that mapped the surface of the Earth. And one of her, I mean, you may have interacted with some of her stuff. One of her transmitters is on the moon, still transmitting.
Oh, funny. Yeah.
Long after, she's gone, but the transmitter's still up there beeping away. Anyway, I mention her because not only was she a historical figure in the world that you were in there for a while, but she taught at Caltech in the 60s.
Okay.
And she used to tell me some stories in confidence, which I won't repeat now, but she interacted with some of the great minds of, the late Richard Feynman.
Yeah.
She hung out with. Yeah. And it just sounded like so much fun. Like, here you are, like a person like her or you with extreme intelligence, that can be a very lonely life. It's like you speak a language that very few other people understand, and it can be very frustrating and isolating, I imagine. But what she described it sounded so much fun because there you were with these people who were like you, who all speak that language, whether it's the language of mathematics or, physics or whatever it is. But there was also a kind of free thinking, think outside the box, kind of rebellious quality to science in those days. Did you experience any of that, or is it like the rest of the culture where it's become much more conforming and corporatized and monetized?
Definitely, there's some of all of that. I mean, it is a unique kind of place to be. I really enjoyed my years at Caltech. I mean, it was kind of the highlight of my life, just the access to enormous telescopes. I spent a lot of time at the Palomar 200-inch telescope, which is just a gorgeous instrument to work on. The grad students were fun. There was a real sense of camaraderie among grad students and professors, not very hierarchical. Just, we're all in this together. We're all exploring. This is a lot of fun.
Right.
So, that was great. We played D-League softball, which, we'd carry beer around the bases with us. That's how serious we were. And spilling the beer was the worst kind of error one could make. And, we didn't even pay attention to who won. We were just out there having fun. So it was definitely a fun environment. And a lot of these folks are explorers, but they're also all career oriented. And so that can overwhelm, fun discussions because everybody's focused on making a splash. And, it actually, science is something that turns one of our vices, if you will, into a real strength because people want to get famous and overturn paradigms. If you can show that Einstein was wrong, I mean, that's a big deal. So science is constantly trying to tear itself apart because of this kind of vanity, if you will. And so all of this careerism does have some real purpose then in kind of questioning the whole paradigm and not taking anything at face value or by what people have said, or, you go check for yourself. That's one thing I really love about physics and astrophysics is you're asking the universe, who are you? How do you work? Not, hey, let me tell you how I think you work. You're not mansplaining to the universe. You're letting it tell you what's up. And
that's a great phrase.
Yeah, I had never done that before. It's kind of
mansplaining to the universe.
Right. That's
And
what
there are
philosophers do.
answers. Right. I mean, yeah, I remember saying something, writing something in graduate school, and one of my, I said so and so, whatever, Darwin proved, blah blah blah, and the professor wrote, "There's no proof in psychology. Proof is only in physics and mathematics. Like, don't even use the word, right? You don't prove anything. We're just mansplaining to the universe, I guess." Yeah. So it must be satisfying when you design and conduct an experiment properly and you do get an answer,
Yeah.
whether
And
it's right or wrong.
you learn new things. In fact, once I was a science fair judge in Seattle, and there was a middle school group, and I think it was some sort of the finalists from their own school. So these were some of the better projects. And so I found one project I really loved because this kid was testing reaction times as a function of age and dropping a ruler and, between somebody's fingers, and then they would grasp it as soon as they saw it falling. And he could measure then, how fast did you grab it? And his hypothesis was that the young would be much faster than the old. And he saw that it was quite the opposite, and he was baffled. And so he devised a new experiment to test, well, is this what's going on, or is it that? If they can't see my own face, if they can't see my hand, can we get to the bottom of what's really happening? And he would come up with a second hypothesis, and then nope, that's not what happened either. That's not what the experiment showed. And it was fantastic because this kid was really exploring the truth and not letting his hypotheses rule. Whereas most of the kids feel like the point of the project is to prove their hypothesis.
Right.
And even the other judges, who are often school teachers, didn't understand why I liked this project so much, and one of them even said, but his hypothesis was wrong. Oh my God. So
that's the point.
Yeah. No. And so this kid was definitely listening to what the actual universe had to tell him. And that's how it's supposed to work.
Right. Yeah. Yeah. My first thought would be that the older people are better at, what you said, at reading the kid's face and knowing when he's about to let go of the ruler.
Mm-hmm.
But he eliminated that. What did he do? Put a wall between him and the subject or something? And or a mechanical release.
This was 25 years ago or so when I did this. So I don't remember what all he did, but it was definitely, he had some interesting ideas about what might be happening. The first ones were not right. And so he kept pushing until he found something he thought was the right answer.
Yeah.
Or consistent with his findings.
Right.
So yeah, I thought that was really, really great and a good demonstration of the core of science. And I want to say that humans are natural scientists. I mean, 50,000 years ago, natural scientists observing the world around them, and keen observers, noticing patterns, picking up on subtle, clues, and piecing together cause and effect. And that's a very powerful capability that we've always utilized. And it's innate in us.
It drives me crazy. And this is something I want to talk with you about, because I think it's something we share. Some of the pervasive sloppy thinking, I know you've read Civilized to Death, so you've got a sense for some of my bugaboos. Thank you. That's an honor.
Well, and I listened to it first. I'll just, as a tangent, I listened to it on audiobook at first, and I was doing chores like splitting wood and stacking wood. So you can spend most of your brain cycles actually not thinking about the task. You can think about what you're bringing in. And I listened to some of those chapters probably 3 or 4 times. So you have, I mean, my voice to you isn't that familiar, but your voice to me is quite familiar. and then, I've got the book right here. I got the book, and I've really enjoyed it. I think, it's a well executed set of arguments that really does expose a lot of sloppy thinking. And it's kind of amazing how sloppy some of this thinking can be.
When it aligns with the sort of power structure, right? The powers that be, it's amazing what you can get away with.
Mm-hmm.
It's just, the neo-Hobbesian thing, and, everyone died at 40. Like, how many times have I heard that? And, and it just, At this point, I normally don't even say anything. It's like it's, fighting the incoming tide with a bucket. It's just like, this isn't about what's true. It's about what
Right.
feels good to believe.
Yeah, it's something that seems obvious to people without having one bit of real contact with the truth.
And they
That,
say it with such confidence.
oh yeah.
So like Steven Pinker and his, I got an email a few months ago from a publicist recommending Steven Pinker for this podcast to promote his new book.
Mm-hmm.
And I was like, you're barking up the wrong tree. I mean, if I were a slightly different person, I probably would have invited him on and said, what the fuck, dude?
Mm-hmm.
But, I don't like those kind of conversations.
Right.
Okay, I know I said that it was my last question, but this is a quick one.
Mm-hmm.
Calculus, relativity, mathematics. Do you think of these things as having been invented or discovered?
Yeah, no, I really love that question, actually, because I have a strong feeling about that. Discovered. Absolutely. We didn't make up numbers. The sun is not confused about one proton joins another proton and makes a deuterium with 2 nucleons, and those create, join to make a helium with 4 nucleons, 2 protons, 2 neutrons. If it couldn't count, if numbers didn't exist and didn't have to add up, it would be a crazy world. If area wasn't the square of the side length,
Right.
It would be a crazy world that wouldn't work. If multiplication, division, calculus didn't exist, it would be a crazy nonsense world that couldn't work. And we have stumbled on those rules. We didn't, in fact, I would say we didn't really discover them in a sense. I mean, I definitely prefer discover to invent, but I think stumbled on is better than discover. Yeah, just being alert and noticing. Yeah, absolutely. I don't think any of these are human created. Now we created symbology around them, but the individuals themselves aren't important. If Einstein had never been born, we would certainly have relativity now. We would certainly have quantum mechanics without Schrodinger and Dirac and all those folks. We'd understand the hydrogen atom without Bohr, because that's what's real. That's what's there. And anybody who looks with, enough acumen is going to see the same thing. And to the point where the equations that we write down in the textbooks would look exactly the same from an alien species in another galaxy.
Right.
I mean, they'd use different weird looking symbols, but the expression would be the exact same. The relationships embodied in those equations have to be the same, because that's the universe and what it actually is doing. So as long as you're able to listen to that universe and transcribe it in some, faithful way, you're going to get the same result.
You said listen to the universe, and that makes me think about the overlap between mathematics and music.
Mm-hmm.
Are you a musician by any chance, or what's your relationship with music?
My relationship with music is shoddy. I'm appreciative. I can make some music sometimes, but it's painful to watch. Like I can learn a Beethoven piece that I really love on the piano, but I have to dissect it into little pieces, and I'm not a sight reader for music. And so It's a long process that gets into muscle memory, and then I can go.
Right.
So, but yeah, I've been fascinated by the mathematical relationships in music, the harmonics and all the tonal qualities. So there's definitely a lot to it.
Because I mean, when I listen to Bach or the Beethoven, particularly Bach, it's like I'm listening to mathematics,
mm-hmm.
And this leads to the next question I wanted to ask you and sort of explore a little bit, is the sense of enchantment with science, right? Like you mentioned a Pythagorean formula earlier with, I think, the side of the triangle. And Pythagoras and people in that era were there was no difference really in a sense, between what we now call science and what we now call magic, right? There was this sort of magical, I think Kepler was, his mother was what we would call a witch, a mystical healer. And Kepler himself believed in all sorts of bizarre things and, frogs being created from, rags in the corner and all these crazy things. But it's interesting how these things have sort of been disentangled to some extent in the hard sciences. But like when you were a young kid just starting to wrap your head around this stuff, did you have a sense of like, wow, this is magical? This is a world that's very mystical, and did it pull you in that way, or was it something else?
I don't think so at the time. I think I moved more in that direction in my, last few years, but I think early on it was more, prone to seeing the mechanical in the world. Now, a fascination certainly with the fact that one could understand the trajectory of a ball thrown across the room, or any number of observations that we might make, that there is a mathematical basis. And I thought that was really fantastic. Thought, why is that even true? Doesn't have to be true, but it certainly seems to be that there's a foundation that the universe appears to abide strictly by a set of rules with no known exceptions.
Were you raised in a religious environment?
I was sort of a milquetoast kind of, I was raised in Chattanooga, Tennessee, and a part of Methodist church. But we were, I would say during my childhood, we probably attended 60% of Sundays. We would go for some long stretches without going to church. So it wasn't kind of hardcore in any sense, but
So
definitely a religious foundation. Yeah.
But it sounds like there wasn't a strong conflict between your scientific sensibility and a religious sensibility.
No, the Methodists, at least the churches I went to, I mean, I got turned off as a 6-year-old when at Sunday school, the Sunday school teacher was saying, no, there are no dinosaurs because they're not in the Bible, and it wasn't time for that. So, God might have put fossils in the earth to kind of mess with us or something, but I was like, I don't know. But
you were 6 and you're already like, nah.
I don't really like that idea, that explanation. That feels a little false.
Yeah.
But I stuck with religion until I was a teenager, and then started, I guess, one of my departures was wondering how it could be that any God that I thought was worthy of praise and love could be as vengeful as the Old Testament God. And so I thought, it really bugged me that according to the rules, that any child who's born without being baptized is condemned to hell for eternity. So even if they die as a toddler, as a just delightful baby,
Yeah. Right.
would be condemned to eternal hell. Not my God. That's not what I want. And so the only way I could get away around that is that he would give everybody another chance and keep giving them chances through kind of a reincarnation until they lived a life that deserved heaven. So that's kind of where I went with it. But eventually that became hard to maintain as well, and just kind of walked away at some point.
Yeah. Yeah. So let's get into, recovering physicists. Like what happened? Why are you not still designing instruments and running experiments?
Yeah, well, a lot of answers to that. But one, I guess I would say, is that I became aware really in my first year teaching at UC San Diego that the energy story was not in the bag for modernity, that fossil fuels were finite, that we could hit a peak oil. And I was very concerned about peak oil at the time, that, our economies could crash if we have a year-over-year decline in that crucial supply that, ran 85%, fossil fuels, 85% of the energy in the world. And some things utterly dependent on it, like transportation and manufacture and
Food, agriculture.
agriculture and concrete, all these kinds of things. So I thought this could be really debilitating. And so we need to, pay attention to this and don't imagine it can never happen, because that's the best way to see it, sneak up on you. So I thought of it as kind of this sleeping giant that could really wreak havoc if we weren't aware of it. And so my efforts at the time were to try to quantify the different energy contributions like solar and wind and geothermal and nuclear and what could each of them do for us. And that's when I realized that it's more easily said than done in terms of the practical differences between those. It's not just this exchange, even exchange of energy equals energy, because the forms and the storability are different. And so, you're not going to have a solar panel powered car that's just, except for stunt demonstrations that are driving under not stored power, but the direct sunlight that's coming in. You get maybe a few horsepower is all that you could get out of it. And so there are a lot of real limitations. And so that was kind of where I spent most of my time. And it was mostly from this point of view that modernity is great and we need to fight like hell to keep it. And I spent really quite a long time in that mode. I wrote a textbook in 2021 that kind of summarized that journey, basically indicating that it's a lot harder than we thought. I mean, the book started out just showing the impossibility of exponential growth, that, there's some surprising numbers that you can throw out, like at 2% growth per year, annual growth in energy, which is fairly historically representative. In only 2,500 years, you would be up to the level of all 100 billion stars in the Milky Way galaxy at 100% capture.
Right.
And you
right.
can't even get to those stars at the speed of light in that time. So physics basically puts a really hard cap on growth. And there are also thermodynamic arguments that you can make that if we kept our energy growth on Earth within a few hundred years, we would be boiling the oceans just because of all that heat that is generated. I'm not talking about greenhouse gases, just the direct heat. And so growth can't continue, period, yet our entire economies are based on growth because we've had this anomalous period of this smash and grab approach to resource exploitation. And, this finite Earth, we've kind of just ransacked as fast as organizations could allow. And the result is a 6th mass extinction that's been initiated. And that's kind of where I've ended up, where, for a while it was, how do we keep this thing going? The textbook was, hey, it's harder than you think and it won't go forever. And so we really need to think about living differently and sustainably.
That wasn't the title of the textbook.
No, the textbook was Energy and Human Ambitions on a Finite Planet.
That's a good title.
Yeah.
And the book is aimed at students?
It is. However, the writing style is very accessible to anybody who wants to look at it. So I would say that probably 80% of people who have ever read the textbook are not in a class.
Why do you call it a textbook rather than just a book?
Yeah, because I wrote it in the style of a textbook with problems so that it could be used in a class.
Oh, I see. Okay. So it's a learning guide kind of thing.
Right. And it's actually free. I put the PDF, online through this University of California resource. I didn't want it to be a paywall kind of situation. So anybody can find this textbook, Energy and Human Ambitions on a Finite Planet. You can get a print version from this print shop that basically just charges the cost of printing. I think it's something like $30 to print this color.
Or you can just print the PDF on your own printer.
You could print the PDF and it probably costs more in ink than...
So was that book was that an expression of what came to be your departure, or of the reasoning behind your departure from that field?
Yeah, I think that textbook in a sense was an expression of anxiety. Of, hey guys, this is insane. Like, this isn't going to work. And we really need to understand that it's not going to work and we need to figure this out. And
so you're like a guy on the bus sitting at the front of the bus and you can see that the driver's drunk and falling asleep, listening to the people behind you chatting about their day. And you're like, guys, we got a problem here. Right. I can see it. You don't see it. But that must have been an extremely difficult place to be.
It was, it's definitely very isolating. And most of my colleagues, I would try to talk to about this. And this is one of the disappointments I had about academia is that people are into what they research and they're very good at what they're doing. They're the best in the world. They can talk to you all day about that and some related issues. But when it goes far outside of that realm, they kind of just haven't thought much about these things. And that was one of the big confusions for me because I'm not the best and the brightest. I'm sort of middle of the road for where I was. Even I'd say as a Caltech grad student, might not have even been quite middle of the road. I saw some true geniuses there, which at least I was at an age mature enough to appreciate these guys and not feel like, depressed that I wasn't at the very top. So there were definitely a lot of much smarter people than me who I couldn't really talk to about these things because they'd never really thought about them, weren't terribly interested, weren't sure if I was even speaking more than nonsense. And never did I come across somebody who said, and I wanted to, who said, yes, I know exactly what you're talking about. I have traveled that road. I was worried about exactly the same things and then able to articulate to me, their concerns that would resonate and say, and here's why I was misguided. Here's why this is not such a concern. Here's what I believe is going to happen that will kind of make everything okay. That never happened.
Mm.
And so all I could conclude was that, yeah, they're smarter people, but it doesn't matter if you haven't really thought about these issues. And if they don't really concern you, that these people are so well rewarded for doing the things that they do very well that why bother, even messing that up? I mean, they could become deranged like me. They could drop out. They could, go into a recovery program, and that's almost shameful. I retired at age 53 because I was done. I was out. And that usually when somebody says that, that means that they've made a boatload and they're, financially secure. That wasn't the case for me, but I could do it, and it was more for just not believing in that system anymore. Because after the textbook, I started getting more ecologically and then more recently anthropologically grounded to put into context, as you would say, who we are as a species and what we're capable of, both for better and for worse. And just in the vast tract of time, I've thought a lot about life and evolution and ecology and how interconnected the entire business is and how the enterprise that we've been involved in is one about smashing and breaking into parts. And that's definitely where I spent a lot of my time growing up in science, was how do we dismantle this complex thing and see the relations, the hidden relations, and the pieces that are comprising it. And now I guess I'm more in a mode where I want to piece things back together and try to understand how the entirety works, the wholeness. And for instance, one of the ways that I can illustrate this is just realizing that I can't be a person, a human, a living being without the sun. We think of that as an inanimate object, but it's really of my animacy. I mean, why would I even separate the two of us? We're inseparable. I can't cleave myself off and say I exist independently of that.
Right.
And that goes for everything I point to. The rocks in the earth are necessary to hold enough air on the planet through gravity that I can breathe. I need all those rocks. My life, those rocks are part of my life. Trying to draw boundaries and cleave and separate has some utility in comprehension, but if you don't try to put it back together and realize that it's all one giant interrelated phenomenon, you can make some pretty stupid, boneheaded decisions about what we should be doing.
You sound like somebody who's taken mushrooms.
This is funny because I get that a lot.
and that's coming from someone who's taken a lot of mushrooms. Okay.
Yeah.
So no insult intended.
And I never have. I am curious, I will have to say, because everything I've read about it sounds like it's parallel to my own journey.
Yeah.
and that it is a sense of oneness, a sense of connectedness. And I'm also really fascinated by Ian McGilchrist's book, The Master and His Emissary, that describes left hemisphere, right hemisphere differences and how the world is apprehended and mental models are built and how they attend to various influences and stimuli and process those things. And so what I came to realize in reading that book is this somewhat described why I was always a little bit of an outlier among my colleagues, in that I was a very contextually oriented, almost case by case person who often realized that we don't even know all the possibilities that, trying to troubleshoot an experiment, what's going wrong. You make a list of 4 things that could be going wrong, and you assign some mental probabilities for which one is most likely that I should tackle, but you might be missing the bulk of the possibilities. So what you think is most likely might still have a low chance of being right. And so, but I also always taught classes that tried to make the physics real and make it part of daily life and observation. And I realized that I just had sort of a more right hemisphere approach, or a mix. I mean, obviously I have a lot of very strong analysis capabilities that we would associate more with the left hemisphere, but just this sort of broader awareness and this contextual linking. And so what I've heard about mushrooms almost makes me feel like it shuts down the left hemisphere. And you're just dealing with this right hemisphere that's trying to take in the whole, trying to understand holistically. But yeah, I've never done it. I'm kind of curious. So I don't know. I've been a teetotaler all my life. And so it would be a big leap, but it's not one it's one that I could imagine trying, because there are no addictive qualities to it. And that's something that I really am sensitive to I saw enough addiction growing up that I just wanted to steer well clear of it. And
it's one of those conceptual mistakes that we make that you were talking about earlier, like to even, refer to psychedelics as intoxicants. It's so different. It's the opposite experience. In fact, one of the worst things I've ever done when when I'd had mushrooms is go around people who have had alcohol. Because on the mushrooms, you're so hyper aware and hypersensitive. It's like the filtering systems that normally remove a lot of perception to allow us to just kind of get through the day are relaxed or removed. And so you're not seeing anything that isn't there. You're seeing what's always been there, but that you normally don't notice. And so when you're around people who are drunk, they're revealed in all their grotesqueness and their vulgar, drooling disgustingness. And it's like, holy shit, do I act like that when I've had, 3 glasses of wine? Holy fuck. It's really interesting. So to even put them in the same realm is so, so different. But I do think, I feel like, what we've been talking about, the sense of enchantment in science, or the beauty of mathematics, right? There's almost like a syncretic awareness of the unity of these things, that I think was much more typical of earlier ages. And now, maybe you get a Carl Sagan or someone who writes about, where the analysis and the aesthetic overlap, in these things. But that's a rare person. I think Einstein was one of those people, and, we could name several of them, but it sounds like you have that like you have the sort of scientific chops, but as you're saying, a much more kind of right brain, contextual, and always wanting to step back and see the larger picture. I feel like I have that too. Like even when you were talking about your colleagues and how, some of them are, certified geniuses or whatever, or smarter. And I'm thinking, but what does that mean?
Yeah.
What does smarter mean?
Right.
Right. Does it mean, because I've known people like that who are just like, wow, like that guy sits in the back of class, barely pays attention, and aces every exam. Like,
Right.
how does he do that? I know he's not studying. How does he do that? He's super, super smart.
Yeah.
But then he also wrecks his car every fucking 3 months, and he's in,
Yeah.
fist fights with his father, and like his life is a disaster.
Yeah.
So what's it mean to be smart?
Well, I can get myself to a place where the word smart is an insult
Right.
because
Because it's limiting.
it can mean narrow.
Right.
It can mean,
Exactly.
yeah.
You're really good at that one thing you do, but you can't step back and see the significance of it or
Right.
see it within the context of all these other things, like what's happening, to global food supply or, whatever it is. And, I often get to this place where it's like you were talking about your colleagues and how they have these narrow fields of interest and awareness. And I'm thinking like, yeah, okay, is that part of this larger process? Like AI. I'd love to get your thoughts on AI. But my feeling as a total, I don't even know what to do with AI. So I'm only thinking of it as a concept. But to me, it feels sometimes like human beings have been a larval stage of something larger than us. And AI is like, to put it in positive terms, it's like the butterfly breaking out of the chrysalis.
Mm-hmm.
And we were the caterpillar, I could also put it in very negative terms, Mary Shelley's Frankenstein, and, we could go down that road. But like, it seems to be part of the process that the larval stage would be very focused on creating the necessary conditions for the butterfly to take flight. And so these genius colleagues' narrowness of interest and concern is actually exactly what's needed and fits into this larger process that it's very difficult for us to be aware of.
Yeah, I can see that point of view. I think my own experience with AI is that, it's an impressive trick, but it is a parlor trick of sorts, especially the large language model. It's how can I complete sentences that sort of look like other sentences I've seen and kind of
Right.
have all the right grammatical structure and make points that are reflected elsewhere.
But there's no awareness behind it.
No, there's
it's
nothing
all
like
just
that.
predictive.
That's
Yeah.
right. And that's where the hallucinations come from. And what I've learned in my limited experience of AI artwork, because that's a place where, I'm a decent writer and I have ideas, so I can spin out words with no problem. But what I can't do is make art effectively. And so I have an idea and I'd like to tell a story with a picture, and it would take me weeks if I wanted to try to, and it wouldn't be very good, right? So I just don't have that talent. And so within a few seconds and however many, megajoules it took, I can have some artwork produced by AI that has, is better looking than what I could do. But what it can't do is tell a story. It can't get relationships. And I have a post on my Do the Math blog about all the failures, just sort of a gallery of here's what I prompted, here's what I wanted, and here's what it spit out. And here's how it's so stupid. An example would be, I wanted a picture of a guy standing on a branch with a chainsaw, cutting off the branch between himself and the trunk. So you already have a mental image of that. A 5-year-old would have a perfectly good mental image of that and understand what it's trying to communicate and like, oh, you shouldn't do that, right?
Right.
I struggled mightily to get AI to create that story. Yes, guy, branch, tree, chainsaw, those elements were always present, but how they related to each other, where the cut was being made. Sometimes the guy's foot turned into a chainsaw. Sometimes the person would be doing a vertical cut into the trunk, which, there's no reason to ever do that. And so
Right.
again, it's context. This thing doesn't know that that's not how you use a chainsaw.
Right.
And I wanted a picture of a scale, a balance scale, with on one side a smartphone and on the other side a bunch of animals. Again, you've got an instant picture, and you could even guess why I'm trying to compare those things and weigh them against each other. But it was impossible to get. I could get all the elements. There's always a balance scale. There's always a smartphone. There are always animals. The animals were all over the place. I couldn't get them all into one side. The smartphone was sometimes hovering over the balance scale, impossibly.
Right.
I mean, just weird stuff. It can't. So I'm not so keen on the idea or convinced that AI from this evolutionary path can do anything really interesting.
What
It
about
can.
in math? Can you upload an extremely complex formula and have it solved by AI with reliability, or does it hallucinate within mathematics as well?
I think it's a completely wrong tool for doing that kind of thing, because what it's going to look for are examples of, and it's been terrible at math. I mean, it can't add 2 plus 2, or it couldn't in its earlier phase. I think they fixed those glaring things by basically resorting to some other engine, which is the typical, computer engine, but not the AI itself. So, I mean, something like Mathematica or Wolfram's work is how you would actually do that, because that's non-hallucinatory and it's applying the mathematical principles and not just, AI is doing something that'll look okay, that'll look good, but it doesn't have to be rigorous. There's no rigor in it. So I think it's the wrong tool for that kind of work.
Interesting. Well, I mean, I kind of hope you're right, although the economic implications of that would be catastrophic, given the amount of investment that's going on right now into server farms and all that.
Oh, sure. Well, the thing is, I've done a number of, Google now integrates an AI overview into its results. And I do find myself looking at it, and sometimes it's useful. Sometimes I'm suspicious. And sometimes when I actually know the content, it's a total, like I did one the other day that was, I wanted to find out the track record for SpaceX explosions in 2025, because I'd seen something in the New York Times that 3 out of 4 launches in 2025 exploded in the air, and there was another on the ground. So I thought, okay, I want to get that sort of the details straight. So I did a Google search that was something like SpaceX explosions 2025, something simple like that. And the AI overview is there are no instances of verified explosions or something like that from SpaceX launches in 2025. This is a misinterpretation of headlines or whatever else. I was like, what, are you kidding me? And so I look more closely, and yeah, absolutely 3 out of 4 had exploded in the air and another one on the ground. And it made me wonder if the creative euphemisms that they use for, unscheduled rapid disassembly, or a kinetic event or something.
Yeah.
If AI is basically saying, well, the main source, SpaceX, doesn't call it an explosion. It was not an explosion. It was a rapid, whatever. And so I wonder if it's fooled by that or what. But it was just this total flub on an important issue.
Yeah.
And I've seen other big flubs before that are just kind of jaw-dropping. And so, I don't know.
Interesting. Well, that makes me wonder, is the real utility reality manipulation? Right? Because if you can, if AI becomes as ubiquitous and people become as dependent, I mean, you can't say I don't want it in my phone. It's there. You can't say I don't want it in my computer. It's there. They push it in. And so then, like everything else, we become addicted to it. It becomes part of our cognitive process, but it's a part of our cognitive process that's outside our personal control. So now, 20 years from now, they can say, no, there were never any explosions of SpaceX rockets. It's been smooth going all the way, and how are we going to prove otherwise? Man. Well, listen, Tom, we've been talking for over an hour, and I don't want to wear you out, but there's so many things I would love to. I really enjoy your mind, and I would love to have access again if you're willing to do this.
Yeah, it was fun. And I'm not at all worn out. I could go all day.
Oh, good.
But I know the listeners will be worn out.
Well, and I've been drinking this big ass mug of tea right here, and what goes in must come out at some point.
That's true. That's just physics.
physics, fluid dynamics
Yep.
are calling my name. Okay, your blog is called Do the Math, and it's at the UCSD. It's on
Yeah,
there.
UCSD.edu. I think it's dothemath.ucsd.edu.
Right. Okay, and I'll definitely put a link to it in the show notes here. I highly recommend it. Since you reached out a few months ago, I guess you were reading Civilized to Death, and
Right.
we've sort of had a correspondence, and I've been reading your stuff since then. And I really, again, I mentioned it earlier, but your last one about how 8 billion people will die, if that's so fucking dumb. It's such a dumb way to think, as you point out. People are going to die anyway. When I call for reduction in global population, people freak out. Like, what? You want to kill the old people? Like, I don't want to kill anyone. Just, we've learned to control population.
I can't keep them alive, though.
Exactly.
There's nothing I could do.
Right. Like, it's so strange. It's like, I don't want to dam the river. I just want to redirect it a little. Like, it's fascinating how, and very frustrating, and I'm sure you've experienced this probably more than me even, but like how rational thought runs into human psychology.
Yeah.
And
the assumptions are crazy often and unquestioned. And so that's where things go wrong.
And it's not a critique of intelligence. Getting back to what you're saying about people being smart and what's smart and all that. I have a friend who's a guy named Voodoo, actually. He's a magician. He's a tattoo artist, but he does magic really, really well. And because we're good friends, he'd do a trick and I'd be like, fuck, man, do that again. And he's like, okay, I'll do it again. And he'd do it again. And he'd do it again. And he'd do it like 5 times. And I'm, looking where I think he doesn't want me to look. I'm looking from different angles. I'm like, it's a scientific thing I'm trying to do. I can't figure it out. And one time I got really frustrated. He's like, look, Chris, don't feel bad. Smart people are the easiest to trick.
Yeah.
They're the easiest. I know where you're going to look because you're smart and you're looking where a smart person would look. The people who fuck you up are kids and dumb people because they're unpredictable.
Yeah. Or chimpanzees, right? They could probably see right through it.
Right. Yeah. Exactly. Yeah. Yeah. It's an interesting thing. But, as you say, the unquestioned assumptions, that's on my list of notes here. Like, what are some of your, most salient unquestioned assumptions? So maybe we can start with that next time.
Sure.
But this time I really just wanted to get a sense of your personal trajectory, because I think it's so interesting to talk with people who've spent a lot of time and effort climbing a mountain, and they get up near the summit and they say, oh, this isn't what I thought. And they turn around and come back down. That's a rare thing.
Yeah. Or that the mountaintop was too bare and actually kind of desolate, and the creek below is really quite enjoyable.
Exactly. Let me go back down to that waterfall and take a nap,
Yeah.
Yeah. There's a wisdom in that I really resonate with, but that I think is, it's difficult to find. There's so many people who say, who condemn it from a distance, but it's hard to find people who have the personal experience and then say, okay, here's what's really going on up on that mountain. And so,
well, and really quickly, just, and connected to your Civilized to Death work, when Europeans came into North America and found the Native American population, it wasn't the situation that these folks were saying, thank you, finally we're rescued. You have food, you have agriculture, you have a lifestyle that we just would die to have. It wasn't like rats scrambling to a lifeboat, at all. They fought tooth and nail to keep their treasured way of life because it worked for them, because it was enjoyable, and because they saw all kinds of flaws in the European style. And almost anybody, any adult who had the choice and went back and forth, stayed with the Native Americans. Europeans were sold. Native Americans who went to the Europeans couldn't wait to get back. I mean, that speaks volumes, whereas we in our culture have zero connection, zero contact, zero experience. And so we fill that void with stories,
Right.
and they're bad stories. They're just not at all right, and they're completely ignorant. And so I think that's a really important thing to realize is that, but you can see it in the evidence. You can see it in how people have responded universally around the world to modernity encroachment. They don't want it.